Recently, I have been exploring Groq. It's Groq with a Q, not a K. It is an inference engine that's supposed to deliver fast and low-cost inferencing, powered by its language processing unit, which is a chip designed to run large language models faster and more efficiently than conventional GPUs. So in this video, we will give it a try and we will configure and use it as our inference engine in IBM watsonx Orchestrate platform. So let's first take a look at what we are going to build. We will create a very simple multilingual bank agent that is capable of performing real-time financial operations by invoking backend Python tools through function calling. And by multilingual, I just wanted to test out whether I could speak in English while the bank agent will respond in Japanese. And the goal is that the agent should be able to interact with us naturally in Japanese and intelligently decide which tool to execute based on the user requests. And within the tools layer, there are two main components. The first tool is the currency converter, which handles currency conversions using a library called currency converter. One thing to note is that this library does not query any live APIs. Instead, it's using some historical exchange rates from European Central Bank for 42 currencies dating all the way back to 1999. We're using this library here just to demonstrate that you can easily integrate any open source Python libraries within this tool calling setup. And the second tool we have here is the fetch transactions tool, which will be used by the agent to retrieve transaction records for a given account from a table in IBM's DB2 on cloud service. And what happens in our application is that the agent will interpret natural language input from the user and decide which one of the tools it should use and process the result and respond to the user in our preferred language. In this case, it's Japanese. I already built this agent, but since our focus is Groq's performance, I built this interface just to benchmark it against OpenAI's GPT-4o mini model. So here we are running the same multilingual bank agent on two different backends, GPT-4o mini on the left side and a Llama 3.37 billion model running on Groq on the right side. Before we give it a try, let's take a look at the system prompt. I defined the system prompt in Japanese, but the English version is just for your reference. We asked the model to always respond in Japanese, even though it's capable of understanding English and responding in English. But here we just want to test out if the model will be able to follow our instructions strictly, only respond in Japanese, even though it's 100% capable of understanding and respond in English. If the user's input start with a $sign, we would like the agent to grade the user and ask how it can assist them. And for task handling, the agent should use fetch transaction tool for inquiries related to salary, deposits, or payment. And it should use the convert currency tool for exchange rate related questions. And we also included an account ID in the system prompt. In real application, this will be passed automatically when the user is authenticated. But here I just hard-coded in as an example for a very quick and straightforward test. And finally, we tell the model that when a tool is called, the agent should read the output from the tool calling and then return the final answer to the user. So that's the system prompt we will pass to both the OpenAI model and the Llama model on Groq. So now let's give it a test and see if both of these models are capable of following our instructions as we defined. So the first test is I will start with a $sign, and you will see that both the model responded with greetings as we asked for, and Groq model is slightly faster than the GPT model. And then let's ask another question, which is last month's salary. In this case, this fetch transaction tool will be called, and what happens is we will connect to DB2 on cloud and fetch the related records from the structured table. You can see that the tool calling has been completed, and the Groq is way faster than the OpenAI model. Let's do one more testing, which is about currency conversion. Let's do 1 USD to GPY. So in this case, we use the open source library to do the currency conversion. Once again, our model on Groq is able to give us output faster than GPT models. Of course, it's a simple test, but it's really just to give you an idea of the performance of Groq. I'm very glad to see it has comparable performance with GPT models. And the good news is that if you already have an agent built with OpenAI SDK, most of your code will remain the same. All you have to do is to replace the client with Groq and of course with a key from Groq. So what I'm using here is I used my Gmail to sign up for a trial account and I get a trial key. I think it's very good enough if you want to give it a quick test like what I'm doing here. The next thing I want to show you is to enable Groq on watsonx Orchestrate. So here I have some commands I run to reproduce this agent in watsonx Orchestrate. If you already have watsonx Orchestrate ADK and the Developer Edition installed on your desktop, then it should be a very quick configuration. So first you'll have to start the local server with the entitlement keys and the credentials you defined in your environment file. And this command will start the local server, but if updates are available, it will pull the latest image from the container registry and then give you the latest version of the Developer Edition of Orchestrate, which is perfect for development and testing purposes. Then you will have to activate your local environments for all Orchestrate command line commands. And then this line will launch the chat interface locally so that you will have a local environment to build your agent in an UI. Also, if you develop your agent in ADK, as I did here, you will have the chat interface to interact with the agent you built. And then these are the commands to import Groq models. So first we will add a new connection where we will store our Groq API keys. And then second, you will configure the Groq connection in the draft environment, and we define the authentication type as key value pairs and with team as the scope for this credential. Then we will set the credentials to store our Groq key in the draft environment, which will be securely stored in watsonx Orchestrate development environment. Once we configure the credentials as a connection, we will import the model definition. It's a YAML file that looks like this. So basically you just need to tell Orchestrate which model you would like to use from Groq. And in this case, we're using this 3.37 billion versatile model. This is a name will show up in our chat interface later. I'm going to show you. Once you go through this command and you run this models list command, you will see something that look like this. So these are the models available if you want to build your own agent. And everything starts with a star emoji, and virtual models are the ones we imported via the model gateway. So as you can see, it's not only model from Groq, but also models from OpenAI. You can use it for building your agents. We have models from IBM watsonx platform as well. And then that's it. So once you're done that, the model is already there in your local development environment. And it will just be business as usual. You import the tools. And then if your tools requires additional libraries, you will have to define them in the requirements file. And then you import the agent. So my agent is defined like this. So in here, I define the large language model I would like to use for my agent, and then the style of my agent, the system prompts, and then the tools, things like that. And once you import the agent, you will be able to see the agent in the chat interface. And one last thing I want to point out, since in our application, we need a DB2 connection. For that, we need to install some additional system dependencies in the runtime container used by our tools. So if that's the case, this is a command you could run to install missing system dependencies. But if your tools does not require additional dependencies at the system level, you don't have to run this commands. Now let's take a look at our developer edition of Orchestrate. This is the agent we just defined in our YAML file. And just quick check that this time we are using the 3.37 billion model from third party, which is Groq in our case. And also we have the 4.0 mini model, which is from OpenAI. So everything you define in the YAML file will be populated in this UI, and you can make changes here as well. I have been running some testing as we build this agent. At a certain point, I encountered this error just because I have hit the rate limit for that day. I'm actually very glad to see this error because that's another sanity check that the model we're calling in this agent is a model from Groq. If you see that, you just need to wait it out until your daily quota got refreshed, and then we can try the agent one more time. This inquiry is asking for the payment history in our accounts. So as you can see that in the reasoning section that the agent successfully identify the tool we need to use in this case is fetch transactions. This is the input we will be using when we call this tool, and then this is what's returned from our DB2 connection. Agent will read this observation or the retrieved result from this tool calling and provide an answer to the user query in natural language. So other things we could test is if we send over a $sign. In this case, the agent should give us greetings and ask how it could help. If I ask for the currency conversion, then the agent should call the currency converter tool to get information about the conversion rate, things like that. So this is what's happened here. Yeah, that's how easy it is to configure Groq models in Orchestrate and use it as the backend models. That's it for this video. If you find it helpful, please like, subscribe. See you in next video.